material for the semester. So we're going to go through this. I may or may not break it up into 2 videos, but this is it. A good way to do this, to see these things, is if you get yourself 4 pencils and try to arrange them. You'll see what I'm talking about in a few minutes. All right, so molecular geometry, the 3D structure. So if you look at a Lewis dot structure, let's look at methane. We've drawn Lewis dot structures before. Look at the Lewis dot structure that, if you really think about it, why would these 2 hydrogens be 90 degrees apart and then these 2 hydrogens be 180 degrees apart? And the answer is they wouldn't. So how do we determine how far, where they're going to be and what the bond angles are and all that kind of stuff? What's it going to look like in 3 dimensions? And in 3 space, it's really important because, for example, in biochemistry, there's a lot of interactions between molecules and things have to fit into pockets. So this is very, very important going forward. So the way we determine it is by counting the sites on an atom. So when we talk about the shape, we can talk about the shape around any atom. So if you have a really big molecule, you may have a whole bunch of different shapes. Typically we do every atom. We don't bother to do it with hydrogen because hydrogen is always going to be linear. But a site is something that takes up space. There's 2 types. There's an attached atom and an unshared pairs. It's very, very important that you realize it's not bonds, it's attached atoms. So if you have a double bond, it's still only 1 attached atom. And then the total sites is simply the sum. So if we look at methane, we look at the carbon. Carbon has 1, 2, 3, 4 attached atoms, no unshared pairs. So remember I said unshared pairs are important? This is where it's going to show up. So 4 attached atoms, no unshared pairs, that means there's 4 sites. So how do we determine how these 4 sites arrange themselves in 3 dimensions? So this is called VSEPR Theory. In case you're wondering what it stands for, it's valence, shell, electron, pair, repulsion. The bottom line is electrons repel. And remember, the atoms are held on by these electrons. So these are what's repelling. The atoms are going to go wherever the electrons go. So they'll move as far apart as possible. So this is where, for example, for methane, you could get 4 pencils and try to hold them in the middle and try to hold them the same distance. And if you did, this is the shape that you would get. Now, for this class, I don't care if you remember the bond angles, the actual numbers. I'm not going to test you on them. But you should be able to say this bond angle and this molecule will be bigger or smaller than the bond angle in this molecule. In Chem 200, they are going to expect you to know those. The shape is tetrahedral. If you were to do a ball and stick, it would look like this. And now, how do we draw this in a 2-dimensional medium like a piece of paper? So what we do is we put as much in the same plane as possible. The wedge means it's coming out at us, and the dashed line means it's going behind. So if we look side by side, you can kind of see it. In real life, it looks more like this. So in real life, what happens is that the electrons from one atom are attracted to the nucleus of the other, and they kind of melt into each other. I just thought these were pretty pictures. You get a better feel for it. This is called a space fill. All right, as I progress, I'm going to develop this summary sheet. All right, so by the very last slide, we'll have everything. So the shape of the clouds, the shape of the molecule, the bond angle, all that kind of stuff. So everything else is just examples. So let's go through it. I am going to do this in 1 video. All right, so if we look at ammonia, so you see you have to start with the Lewis dot structure. So if we look at ammonia, look at the nitrogen there, okay? The nitrogen has 1, 2, 3 attached atoms, 1 unshared pair. That means there's still a total of 4 sites. That means 4 sites. The clouds are going to be tetrahedral. Now you can think of an unshared pair, that's the ball and stick, think of an unshared pair as an invisible cloud. So this pair of electrons repels and it pushes these guys away, but there's no atom there. So it kind of looks like if you took a tetrahedron and cut the top off, right? And this is called trigonal pyramidal. You don't need to know the bond angle. Now why is the bond angle a little smaller? Remember a tetrahedron was 109? That's because an unshared pair is really a short, fat cloud like this. And so it's going to repel a little bit more, where these pairs of electrons are attracted to 2 nuclei. So imagine if you took a rubber band and stretched it between your 2 fingers versus just holding it on 1 finger. So it repels a little bit more. Right? There it is side by side, and there is a space fill. All right. So here's your summary sheet. So this is the attached atoms and shared pairs. Notice these always add up to the number of sites. If there are 4 sites, the clouds will be tetrahedral. The shape, if there are no unshared pairs, the clouds and the molecule are the same, then just literally, if you're doing it with 4 pencils, take a pencil off. That's called trigonal pyramidal. All right, now let's look at water. Right, so the oxygen has 1, 2 attached atoms, 1, 2 unshared pairs. That means there are still 4 sites in the oxygen. Right? 4 sites means that the clouds are going to be approximately tetrahedral. But now we've got 2 invisible clouds. There we go. So 2 invisible clouds. That means these 2 aren't really there. And so that shape, this is the best one, is called bent. The bond angle is 105. Again, the 2 unshared pairs are going to push the hydrogens closer together. All right, there's side by side. There's really no wedges and dashes because it's flat. There's your space fill. All right. So now hydrogen chloride gas. So if you open the bottle of hydrochloric acid and smoke comes out, that's the gas, HCl gas. Right. So 1 attached atom to the chlorine. No unshared pairs on the, 3 unshared pairs on the chlorine. What am I thinking? All right, that means there's a total of 4 sites. That means there's 1, 2, 3, 4. That means the clouds are going to be tetrahedral, but take your tetrahedron and pull 3 pencils off. It's going to be, you guessed it, linear. And you only have 2 things, that's all you can do. There's the side by side, there's a ball, and there's a space fill. All right, so this is the summary of 4 sites. So if there's 4 sites and they're all attached atoms, tetrahedral. 4 sites where one of them's an unshared pair, trigonal pyramid. 2 and 2, 4 sites, tetrahedral clouds, but bent. 1 and 3, 4 sites, tetrahedral clouds, but linear. All right, catch your breath. All right, this is formaldehyde. We're going to look at the carbon. There was actually unshared pairs on the oxygen, but I didn't want you to focus on that. We're going to look at the carbon. So this carbon has 1, 2, 3 attached atoms. There are no unshared pairs on the carbon. That means there are a total of 3 sites. So if you hold 3 pencils in your hand and you try to get them equidistant and as far apart as possible, they're going to go to the corners of an equilateral triangle. Now in chemistry, we can't just say triangular because that would make it easy. We say trigonal planar. So there's trigonal pyramidal and trigonal planar, so you definitely have to specify. All right, there's your ball and stick. All right, bond angle is 120. There's side by side, there's no wedges and dashes. There's the space fill. All right, so this is the summary with the 3 sites. Okay, in this case, we're going to look at the sulfur here. Oops. The sulfur has 1, 2 attached atoms and 1 unshared pair. 2 attached atoms, 1 unshared pair. That means that there's a total of 3 sites. 3 sites, the clouds are going to be trigonal planar, but we have an invisible cloud. So imagine a triangle and you take 1 corner off. Okay, the molecule is going to be bent. Now, why is it between 105 and 120? Think about that for just a moment. All right, when we go through the rest of the slides here. All right, there it is side by side. There's your space fill. So it's bent less than water. All right, so why is the bond angle closer to 120? There's a couple of answers to that. You can try on your own. Okay, first of all, 4 sites are going to be closer together than 3 sites. And secondly, here you have 2 unshared pairs pushing things down and only 1 is going to push things closer together. All right, now we're going to look at this oxygen here. So this oxygen has 1 attached atom and 2 unshared pairs. All right, that means that there's a total of 3 sites. So here's my triangle, right? 1 corner, 2 corner, 3 corner. Clouds are trigonal planar. So around the double bonded oxygen, it's going to be, so if I take a triangle and I take 2 corners off, it's going to be linear. They're side by side. right? So 3 sites, no unshared pairs, trigonoplanar. 2 sites, 1 unshared pair, so take a corner off the triangle, that's bent. 1 attached and 2 unshared pairs, still a triangle, but we take 2 of them off, that's linear. All right, there's only 2 more. So we're going to look at the carbon dioxide, look at carbon. Okay, carbon has 1, 2 attached atoms, no unshared pairs. That means it has a total of 2 sites. Right? 2 sites, nothing you can do, it's going to be linear. So there's molecule, there's side by side, bond stick, and there's the space fill. And then the last one, nitrogen, pick either of the atoms here. All right, so if we look at the nitrogen, it's got 1 attached atom and 1 unshared pair. All right, that means it's got a total of 2 sites. 2 sites are going to be linear, and there's nothing you can do. It's linear. All right, there's the space fill. And so this is the last slide. So if we just very quickly think in terms of holding 4 pencils in your hand. If they're all attached atoms, it's tetrahedron. If one of them is an unshared pair, take one of the pencils out. Try to get them the same distance apart though. Take one of the pencils out. Now it's trigonopyramidal. Take another pencil out, it's bent. Take the third one out, it's linear. You have 3 sites, all right? 3 sites that's going to go to the corners of a triangle. If there's no unshared pairs, it's trigonoplanar, triangular. If you have take off one of the corners, it's bent. Take off 2 of the corners, it's linear. And then the last 2 are linear. All right, that's it for the class. We certainly had to make some adjustments on your end and on my end, and did the best we could under the set of circumstances. As you know, I have plenty of Zoom hours for you to come in and ask questions, and this is the last of the material for exam 4 and then for the final exam. It's been fun. Best of luck to you. Come by and see me in the spring or anytime I'm on campus.